Hello, bachcho. Let's see the question. The question says that a body of mass 200 gram is tied to a spring of a spring constant 12.5 Newton per meter, while the other end of the spring is fixed at point O. If the body moves about O in a circular path on a smooth horizontal surface with a constant angular speed 5 radian per second, then the ratio of extension in the spring to its natural length will be. So we'll solve this question. First of all, we'll see what will be the key concept used in this question. The key concept used in this question will be centrifugal force causes the extension in a spring. Centrifugal force causes the extension in a spring, and this centrifugal force Fc is equal to m omega square r. Now we have been given that a body of mass 200 gram. Suppose this is a body of mass 200 gram which is tied to a spring. The spring had natural length L naught and this is fixed point. This is point O. Now the body moves about O in a circular path. It moves about O in a circular path and with omega 5 radian per second. Omega is given angular velocity 5 radian per second. 5 radian per second. Now, due to omega, a centrifugal force will act radially outward, which will cause the extension of the spring. So, suppose the spring is extended by a length delta x. Suppose this is delta x. So, the centrifugal force acts radially outward. This is centrifugal force, and due to the spring extension, spring force will act radially inward. This spring force will be equal to k delta x, where k is the spring constant. Centrifugal force will be m omega square. R will be L naught plus delta x. L naught plus delta x. So we will balance force because it is moving with constant angular speed. So there is no acceleration. So force is balanced. So in radial direction, we will have m omega square L naught plus delta x will be equal to k delta x, or from here we will have m omega square L naught plus m omega square delta x is equal to k delta x, or m omega square L naught is equal to k minus m omega square common multiplied by delta x. So we have m omega square L naught is equal to k minus m omega square multiplied by delta x. Now we have to find the ratio x by L naught, that is extension in a spring to the original length, natural length. So that will be equal to m omega square by, this is delta x by L naught, m omega square by k minus m omega square. Now we have been given m is 200 gram and k is 12.5 Newton per meter and omega is 5. So m is 200 gram, that is 0.2 kg, k is 12.5 Newton per meter, and omega is 5 radian per second. So omega square will be equal to 25 radian square per second square. So we'll put the value. We will get 0.25 into 25 by 12.5 minus 0.2 into 25. So that will be equal to 5 by 7.5, that is equal to 2 by 3. So the required ratio is 2:3, which is option C. So this will be the correct option. Hope you all understood it well. Best of luck.